Hi, everybody. Today we're starting the very first section in number sequences. And a big part of mathematics in general, all of mathematics, is to look for patterns. That's really what math is all about. And that's exactly what we're going to be doing today. So I think you're going to really like this. We're going to look at identifying arithmetic versus geometric patterns or sequences. And there's an easy way to tell. Arithmetic means adding and subtracting. Geometric means multiplying. So if we look at these numbers, we can see that they're going up very quickly. In fact, each one, this first term here is 2, and the second term is 14, and the next term is 98. Clearly, we're not adding the same amount, because we added 12 the first time and then we added a much larger number. But if I multiply by 7 and multiply by 7 and multiply by 7, 686, there they are. That is a geometric sequence. When you multiply by a number, it's called a geometric sequence if you multiply by the same number each time. Now this one, she started out with 137 stars and then got a little more tired or made them a little larger, and then she had 125 stars. Now the difference between these is that it went down 12. Now if it goes down 12 again, I'm going to anticipate that it'll be 113, and sure enough it is. And if it goes down 12 again, it's going to be 102. Sorry, 101. Oops, you can't subtract today. There we go. And this is a arithmetic sequence because we are subtracting 12 every time. Adding and subtracting is arithmetic. Multiplying and dividing is geometric. Now this one, it looks like it's going up very quickly. From 4 to 24 is an increase of 20, but from 24 to 144 is 120 increase. And going up to 686 is even bigger. Now we're multiplying by 6, we're multiplying by 6, yes. And are we multiplying by 6? It certainly looks like we are, but maybe we're not. Oh, it's 24. Oops, there we go. God, I can't transcribe today. There we go. Now it's right. So now it's correct. 4, carry the 2, and wait a minute. 60. God, I'm transcribing everything. 864. Now it's correct. I keep missing it. Okay, so 4, 2, 4. Yep, that's the one. So it is definitely geometric. I had suspected after the first 3, but I like to double check and make sure that it actually does increase the way it's supposed to. So now we have 48 buttons in the first box, and then we go to 61, which is an increase of 13, isn't it? Now, let's see. We're going to go to 74, which is also an increase of 13. And I suspect that the next one, if I add 13, I'm going to get 87. And sure enough, there it is. And this is, you guessed it, arithmetic. Okay, is it possible to be both? Well, let's see. This one went from 7 to 14, and then it went to 28, and then it went to 56. Now it looks like we added 7, and then we added 14, and then we added 28. But that's the same as doubling each time. Times 2, times 2, times 2. Oh, it's geometric. It doesn't look very big, but there it is. It is geometric. We're multiplying by 2 each time. This one, we went from 24 to 34, and from 34 to 46. Well, this is an increase of, it looks like 10, and now we're increasing the increase. We're increasing by 12. And then to get to 60, we increased by 14. Now there is a pattern to this, but to be an arithmetic sequence, you have to add the same amount each time. So this one we would consider neither. You see how it works? It is a pattern. It's a nice pattern, but it was not a consistent pattern. Okay, 171 to 151 went down 20. I'm just going to write it right there. That's minus 20. And that one is minus 20. And that one is minus 20. And can you guess which one that is? Sure enough, you're right. It's arithmetic. Okay, we have 70. And then she has 73. And then she has 79. And then 88. Well, let's see. This one went up 3. This one went up 6. And this one went up 9. So again, it's a nice pattern, and it does have a pattern to it, but it's neither. We want to look for the patterns too. We don't want to just be, oh, well, I can't see it, so it must not be working. Now, this one's kind of interesting. We're alternating between negatives and positives, and that means that chances are very good that we're multiplying by a negative each time, because a negative times that first negative gives us the positive. And sure enough, we probably multiplied by -2, and we did. And if we multiply by -2, we get the next number. Wait a minute. No, we don't. We have to multiply by -3 to get the next number. And to get the next number, we have to multiply by, yep, -4. So what's happening is we're getting, it looks like a geometric, and it is an interesting pattern, but it's neither. So in this one, oh, it's getting big really fast. You know what that means, probably geometric. And it looks like we multiplied by 8. Uh-oh, we multiplied by 8, yep. And did we multiply by 8? We sure did. I know that 512 is the next one because I've memorized some of the cubes, and 8 times 8 times 8 is 512. That's one of those things that you want to memorize, and this is definitely which one? What happens when you multiply by a number each time? That's geometric, isn't it? And this one, we went from 55 to 47, which meant we went down 12. Oop, down 12. And then from 47 to 39, we went down 10. And then we went down to 31, which was down 8. Nice pattern, but neither, isn't it? What? What did I do? Down 12. Eight. Down 8? Oh my God, I can't subtract today. Oh man. Sorry, guys. Oops. Yeah, that is down 8 for sure. Oops. I don't know what I was thinking. Okay. Yeah, I do know. Uh, that's sometimes when you do things in your head. I reversed my numbers and messed it up. But anyway, it happens. All right. This time I'll see if I can do it right. I'm multiplying by -9. And sure enough, I did. And then I multiplied by -9. And I'm actually going to check it. And sure enough, I multiplied by -9. That is correct, by the way. And this is a geometric. Oops. All right. This one is interesting, and it is a really cool sequence. Do you recognize these numbers? You may not, because these are sort of big ones. This is 13 squared, 14 squared, 15 squared. This is one of those that you really need to know. That's what they are. So we multiplied by 13, then we multiplied by 14, and so on. This is neither, even though it's a really nice sequence of perfect squares. That's what we call these things. These numbers are called perfect squares. And there's some really cool, easy ways to remember them. Maybe we'll go through it on another video. That's neither. Okay. 2 and 3 and 5. Oh, went from 2 to 3 is an increase of 1. This is a nice easy one. This one's even for little kids can figure this one out. And 3 to 5 is an increase of 2. Very happy little kid. And then we have an increase of 3. So even the little kids know that this is changing, isn't it? And that means that it could be neither. Okay, we have a negative 84 to negative 98. Looks like it's a negative 14 that I added. And then I added negative 14 again. Yep. And then did I add negative 14? I sure did. I added negative 14 or subtracted 14 each time. I like to think of it as adding a negative rather than subtracting. And there's lots of reasons in algebra not to do subtraction. So trust me, you would rather think of it like this. I'm adding more negative to it. But what are we doing? Definitely arithmetic. And this one, 27 to 47 is 20 more and 20 more and 20 more. We added 20 every time, which is arithmetic. I hope I'm not going too fast for you. All right, so we have one. Okay. Well, I don't think the timing matters as much as the sequence. So let's just look at the one power drill in July, 9 in August. No, 3 in August, sorry. 3 in August, July, August, then it should be September. Yep, 9 in September and 27 in October. Boy, they need a lot of drills. Okay, so clearly everybody's buying them up as the fall and the winter's coming up. Must be a hurricane coming. This is a geometric sequence, isn't it? And sure enough, that is September and August are the hurricane seasons down in the south. So that is a geometric sequence. We multiplied by 3, we multiplied by 3, we multiplied by 3, and sure enough, it's geometric. Okay, 162 to 143, that is a difference of 19? I believe so. Nope. How about 20? No, 19. Yeah, 19, sure enough. And to 124 is 19, and 105 is 19. So we subtracted 19 every time. And that is arithmetic. It's really easy to make a mistake when you're not paying attention. But yep, that is a difference of 19 each time, arithmetic. Okay, this one we went negative, negative 19. It likes to mess with me with the 19 thing, doesn't it? Is it? It looks like it. No. Okay, negative 194 and negative 19. It's going to be 3, carry the 1. Uh-oh. 1, carry the 1, and that's 2. That's not it. Oh, yeah, it is. Negative 213 and 19 more. I can't subtract today. I don't know what's wrong with me. That is 31, isn't it? No. What the heck? Oh, they really want to mess with me, don't they? Because if I go 19 more, let's see, I took off 19 or negative 19. And if I add negative 19 again, I end up with negative 232, which isn't enough. And so I did minus 19, which was the hard one. And to get to this one, we took off, looks like minus 16. And to get to this one, it looks like we went down minus, God, this is weird. It's like very inconsistent. 17 maybe? Oh, was this one 18? Is that what I did? No. Sure looks like 16 to me. Yeah, that's 16. And then we went down, I really can't. Oh, 13. No, it's right. Wow. My brain is just not working today, but this is a sequence and it is interesting. We're adding negatives and we're changing it by 3 each time, but that is neither because it isn't consistent. Kind of scary looking. Calculator would have been handy right there, especially when your brain isn't working. Okay, so 659. Oh, okay, here we go. 659. 659 and 659. Okay, so this one is called an identity function or an identity sequence, and we just keep getting the same thing over and over again. Well, there's 2 ways, actually 4 ways to do this. We could multiply by 1 and multiply by 1 and multiply by 1. That's called the identity for multiplication. But we could also add 0 and add 0 and add 0 and so on, which is the identity of addition. There's also an identity of subtraction, which is minus 0, and an identity for division, which is dividing by 1. But this is both. This is one of the few that you can actually think of as being both. And I think the identity function is the only one that really overlaps the two. So if you were to look at sequences, I suspect this is true. Now, this is called a when you make a conjecture in mathematics, and my conjecture is that geometric sequences and arithmetic sequences, this is called a Venn diagram, that their overlap part where they have an intersection is in the identities. Now, I don't know for a fact that it's true, but I can definitely prove it. And I'm sure it's been proven lots and lots of times. And it's such an obvious conjecture that I'm sure somebody's done it before. So there you have it. It is definitely both, isn't it? Way more information than you wanted. All right, what do we got here? Looks like we went up 17, maybe. Oh my God, I can't add today. No. 27? No, it's 17. All right. Okay, so it went negative 17. I added negative 17. And oh, luckily I added negative 17. I can see that one. And then I added negative 17. Yep, I did. So that is definitely arithmetic. They want to get me with that 17 and 19. And we're almost done. Okay. Lola goes to the gym 3 times per week. If you track the number of visits she has taken over time, what kind of sequence will you see? Well, if you need to, you can write it down. She goes 3, and then you're supposed to track the total number of gym visits that she goes on. Then the next week it'll be 6, and the next one it'll be 9, and the next one it'll be 12. And hopefully she continues. And this is arithmetic sequence because it's increasing by 3 each time. They wanted to trick you with the word times, didn't they? Come on. Oh, well. Okay. It's usually tells you you got it right. Okay. This one, website traffic varies between 79 and 153 visitors per month, varying with the amount of interest in advertising. So we don't know what kind of sequence this is going to be. And chances are very good it's going to be neither one because it's just going to, could be anywhere from 79 to 153. So it's neither. The monthly rainfall in Savannah's town varies widely between 5 and 65. If she tracks the monthly rainfall, it's going to be neither again. It's because it varies. Anything that varies is not consistent. So it's neither. I mean, in a really weird world, it really could work out for a certain amount of time, but eventually it definitely would not be a sequence. Uh, Cool it by 7 degrees each hour. If you track the temperature for the first few hours, what kind of sequence will you see? So it's going to go down, it's at room temperature, say 70 degrees, and it's going to go down 7, and that's going to be 63. Sorry. It's going to go down 7, and that's going to be 56. And then it's going to go down 7, it's going to be a 49, and so on. So this is minus 7. That is arithmetic, isn't it? And hopefully it gets down to 0. where it belongs. Okay, between 2 and 5, we don't know what kind of sequence it's going to be, so it's going to be neither. If you don't know, then it's probably going to be neither. All right. A startup company has 16 times as many employees each year as it did the previous year. So it starts out maybe 2, like Apple, and then the next year there's 32, and the next year there's 16 times as many of that, which is 512, and then there's 16 times as many of that, and that's a lot of employees, isn't it? 800 and whatever. I can't do it in my head real quick. So anyway, or 8,000 rather, and something. So this one is going to be times 16 and times 16 and times 16, and that is geometric. And you're going to lose 5 pounds less each month than he did before. If you list the weights over time, is on a diet and weighs 5 pounds less each month than he did before. So maybe he starts out at 250 pounds and then he's at 245. This is a very difficult thing to do, actually, dieting, but it is definitely arithmetic. What tends to happen is you lose less and less over time. That's generally what happens. You lose a huge amount at first and then less and less. But this one is based on what they told us. It is definitely arithmetic, isn't it? He's losing 5. And for a total of 10 times per day, if you write down how many times she checks her email daily, what kind of sequence will you see? Okay, it doesn't say the total number of times she checks. And then it's going to be 10, 10, 10, 10. And remember, that's going to be both because you can multiply by 1 or you could add 0. So that's going to be both. And it looks like we have 1 or 2 more. 6 times as much money as the year before. This is times 6, times 6, times 6. Maybe it makes 10,000 the first year, makes 60,000 the next year, makes 360,000 the next year, which is the kind of sequence you want to see. That is geometric. And we have one last one, and then we're done. Let's see. Each hour, the line to buy concerts is 3 times as long as it was the hour before. Oh my goodness. This is a geometric sequence, and this is actually how it works. There might be 2 people in line, and then 6. And then if you wait an hour, there might be 18. And then if you wait another hour, this is probably 2 a.m., maybe 3 a.m., 4 a.m. And then all of a sudden it explodes, doesn't it? There's 3 times as many. 3 times as many would be 54. And then 3 times as many would be 162, and so on. So 5 a.m. and then 6 a.m., then the line is just too long. So this is a geometric sequence. And I hope you guys will try it yourself and get to your 100, okay? Bye, guys. See you back again.